In our previous lecture, we just added on this API for mine. And if you recall, we manually requested for mining to be performed. What we want to do now is to make this an automatic request first by adding on a method. Let's access projects, then block. Then our blockchain.go folder. Here we have our mining method. It's said that it takes 10 minutes for mining, so for example, we may want to automatically mine every 10 minutes from our backend. Let's try writing this just for demo purposes. And regarding how to do this, first let's scroll all the way to the top, and underneath our section for import, we'll add onSync. And under our const, we'll add mining timer sec. And for this, let's say we want to mine every 20 seconds just for our demo. For our difficulty in this case, it's 0 threes, so mining will be completed almost instantly. But in the real world, this mining difficulty will be different. Let's access mining difficulty right now. We have our valid proof, and the longer the zeros, the longer it takes. Once this is done, then we move on to the next mining. This time, we're just working with 3 zeros, which is short. This will be done quickly, but let's try making mining an automatic process so we can do an actual simulation of mining. Now here, we have mining, and first we want to create a lock. For this, we'll go back to our blockchain struct, and to this blockchain struct here, we want to create a lock for this, so we'll add on mux sync mutex. This is what we want to include. Then once more, we'll go back to our mining. When we call on mining multiple times, we don't want to keep on calling it when mining is called the first time. So first, we'll lock this by adding on bc mux. Lock here. Later on, we'll use a timer to call on this multiple times, but for our first time of mining, we'll lock this, and when our method comes to an end, we want to write defer bc mux. Unlock. This means even if we have, let's say, 5 routines accessing mining, the one who removes the lock first gets to perform mining. Let's add on one more thing. When we're mining and our blockchain transaction pool is empty, meaning we don't have any transactions, then in that case, we'll write return false, meaning no mining will be performed. Our transaction pool is empty and no one is sending or receiving cryptocurrency, and when in this situation, the miner will continuously be rewarded. In the real world, even if we have an empty transaction pool, mining is possible. But in the 10-minute time frame, the probability of having no transaction requiring mining is close to 0. So mining an empty transaction doesn't happen, but as a possibility, it does exist. And this is how blockchain programs are run. In our case, in our current demo, we don't have anything in our transaction pool, but our blocks are getting chained together. And this may be hard to understand. So for this demo, we'll write if our transaction pool is empty, we won't do any mining. Now onto the step where we request for repeated calling. We'll write func bc blockchain start mining. Then, first we'll run bc mining. Then this time we'll use time after func, then time, second, then what we previously wrote, which is mining timer sec. After 20 seconds, we want to start mining. So when start mining is called on, mining is done first, and here we're locking. I think this will be completed within 20 seconds, but if it's not completed, we can't move on to the next mining because we have this lock. If we're done mining within 20 seconds, then after 20 seconds, we'll start mining with this. Once more, we'll perform mining here. And I'm assuming that this mining will only take 1 or 2 seconds, and after 20 seconds, we'll start mining again. We just wrote codes to run a program that will repeatedly perform mining. Now let's access blockchain server, then blockchainserver.go. We'll go back to this, and we want to add on a method where we can call on our start mining that we just created. It's similar to this method. Let's copy this, and this isn't mine, but let's rewrite this to start mine. Then, once we have our blockchain, we're going to call on start mining instead of mining. And for our results, we're not going to make any decision, so we'll remove this and we're also going to remove this section for when we fail. We're going to place our success directly into M. Now that we've gotten this far, we want to register this. So this time we want to enter start after /mine. And in this case, we want to run start mine. Now let's test this out. We'll restart our blockchain server and also our wallet server and access this from our browser. Here I have my browser pulled up and this is person A's wallet's UI. Next is person B's wallet UI. Then next is /transactions, which is currently empty. And next is /chain, and we currently have a block from our blockchain. With this condition, we want to call on start mining. We have /mine/start, and let's run this now. And when we do, we get message success displayed. Right now our transaction is empty, so we aren't performing any mining. From now, let's create a transaction where person A sends cryptocurrency to person B. Let's include an address and an amount. Let's say 5.0. We'll click on send, then OK. We'll access transactions and refresh. Now we see that the transaction that we just created is stored here. After 20 seconds, mining will start and this transaction will be removed and be added onto this chain section. I'm going to go back again and refresh our transactions. Now we see that it's empty, and when we access our chain and refresh, we see that the transaction we created with the value 5 has automatically been mined. So when you do want to automate mining, all you have to do is create mine start. If you think that automatic mining is difficult, then you can perform mining by hand and confirm the transactions as you go. Now let's move on to our next lecture.